Assalamualaikum and hi everyone. My name is Umi Sarfina binti Rosmati with metric number E10116. I will be presenting about the adaptive position control of DC motor for brush-based PV cleaning system. So my project team consists of me, Umi Sarfina, and my supervisor, Dr. Syed Zahrul Islam, and my co-supervisor, Dr. Nur Hamizah binti Nasir. So for the presentation outline, I will be explaining chapter by chapter, which is introduction, that is consists project background, problem statement, objectives and scopes, while at the slide 6 to 11 there are methodology, where it describes about the hardware and circuit design flowcharts of the brush-based PV cleaning system, workflow of dust removal rate testing, workflow for data collection of motor parameters, hardware setup and motor specification of DC motor. Next, on the slide afterward, there are results analysis of graph for carrier motor, cleaning brush motor and dust removal rate. Next, I will be presenting about the conclusion and recommendation for this work and the published paper of case 2021. Automatic PV cleaning system is a system that cleans the surface of PV where it is expected to boost energy production by 10% on average. The dust is a significant factor that affecting the efficiency of a PV. It can reduce its efficiency by up to 50% depending on its environment. There are prototypes that has been built by engineers and makers that has a concept as a robotic mechanism which consists of motors and microcontroller. It is function as the same as other prototype where it cleans the PV from dust accumulation, bird droppings and others. These prototypes are to overcome the possibility of staff accident and any health problems due to dust, as the solar panel are implemented on the high place such as rooftop and solar farm. So there are limited studies of specification of the motor use and optimum speed for the PV cleaning system implementation. So the objective for the project is to develop a control system of an autonomous PV cleaning brush controller using the DC motor driven brush controller. And the second one is to analyze the DC motor parameters, motor rating, torque and speed while deploying an autonomous PV cleaning brush controller. So it is designed by using a microcontroller embedded with motor drivers and 3 DC motors that activate by a time-based program. It consists of 2 carrier motors, which is 1 cleaning brush motor that rotates the cleaning brush. So for the second scope is the carrier motor is to move the cleaning brush across the PV, while the cleaning brush should be able to clean the PV and withstand the brush weight and exert sufficient force during the cleaning. Performance of the motor is measured in terms of motor rating, torque, speed and price of the motors, determining the suitable motors to move the brush with suitable speed and adequate torque for the motors to withstand the weight of the brush. So here is the hardware and circuit design. There are 2 carrier motor on the upper side and the lower side and 1 cleaning brush motor, and on the other end of the cleaning brush would be a bearing that would rotate simultaneously. So here is the motor control board system where there are Arduino Mega, MTD10A which is the carrier motor driver module, L298N the cleaning brush motor driver module, the 4 and 5 is the carrier motor 1 and carrier motor 2, which is the upper side and the lower side of the carrier motor. And the number 6 is the cleaning brush motor, and number 7 is the real time clock application. So here is the flowchart of the brush-based PV cleaning system, where cleaning brush is installed in its initial position, where the RTC check the current time, whether the current time is equal to the set time. If yes, the system will proceed with the carrier motors and cleaning brush motor move forwards, which is in rotation of clockwise, and delay for 3 seconds at the other end of the PV, and then proceed with rotate backward and delay for 3 seconds at the initial position. And then RTC will check the current time and compare it with its set time. If not, the cycle will repeat until the set time ended. So here is the workflow for data collection of motor parameters, where attach the brush to the motors and turn the brush controller on, and then measure the current, speed and torque of the motor using the appropriate measurement tools and observe and the recorded data. So here is the reflective tape, glued at the cleaning brush rod, and here is the reflective tape that are glued at the carrier wheel's rim. So the torque of the motor are calculated as below. Carrier motor is focused for translational motion, while cleaning brush motor focused for rotational motion, where it controls by the microcontroller and send it to cloud storage and data storage for comparison of PV efficiency and energy yield. So here is the implementation of brush-based PV cleaning system at the PV installation site. So for motor specification of DC motor, the carrier motor, the overall weight of the system is 6.98 kg with number of brush of 18 slot, and the static coefficient of frictions between rubber and steel is 0.64, and the rated torque of the carrier motor is 2.9 Nm. So the normal force of both wheel is 34.23 Newton with sliding threshold of 43.57 Newton. The carrier motor should be able to exert force less than sliding threshold, where the exerted force is 22.83 Newton, which is proof it is less than sliding threshold. So for the cleaning brush motor, according to the datasheet of the supplier, the motor have torque with load of 0.22 Nm with rated speed of 200 rpm, and the weight of cleaning brush is 2.93 kg with calculated motor torque of 2.64 Nm. To conclude, the cleaning brush and carrier motor are capable to withstand the weight of the cleaning brush and move smoothly along the PV and exert a sufficient amount of force during cleaning. So for results and analysis, here is the graphical form of carrier motor, where it focuses on power and torque of carrier motor. The increment of value on torque and power produced from the motor, the power and torque remain the same at the 0 to 8 pieces of brush slots, and as the torque increase, the power of the carrier motor also increase as there are weight changes of the number of brush. For torque and current of carrier motor, as the torque increase, the current of the motor also increase. So the torque produced of 9.167 Newton meter, which has 18 brush slot with the current flow of 2.4 ampere to move the carrier motor. For speed and torque, the speed is constant, and the increase of torque shows that there are changes of load weight and carrier motor moves to its full capability. The coincidence points of this carrier motor that motor speed is at 30 rpm with torque of 8.403 Nm and number of brush of 15.5 slots. So for clean brush motor, it focuses on the same parameters as before, which is power and torque of cleaning brush motor. 12 brush slots, the power produced is 3.6 watt with torque of 0.405 Newton meter, and then drastically increase to 14 brush slots where it produced 16.80 watt with torque of 1.925 Newton meter. It may caused by the sudden weight changes of the brush slots. At full load of 18 brush slots, the power produced is 19.20 watt with torque of 3.015 Newton meter. For torque and current of cleaning brush motor, it produces similar graph as power and torque of cleaning brush motor, where there are drastically increase of current and torque from 12 to 14 brush slot with current of 1.4 ampere and torque of 1.925 Newton meter. With full load 18 brush slot, the motor needs 1.6 ampere with torque of 3.015 Newton meter. Lastly, the speed and torque of cleaning brush motor, when there are 0 brush slots which is 0 load, the speed produced is 21 radian per second with torque of 0.057 Newton meter. At 8 brush slot, the speed produced is 18.221 radian per second with torque of 0.198 Newton meter. At full load of 18 brush slots, the speed produced is 6.368 radian per second, equal to 61 rpm, with torque of 3.015 Newton meter. With 18 brush slots, the brush covered 90% of PV surface area, where it achieved a highest percentage of 86.80% dust removal rate, with speed of 6.368 radian per second, equal to 61 rpm. But for 5 brush slot, the dust removal rate is 49.4%, where it covers only 20% of the PV, with speed of near to the no load speed, which is 189 rpm. The test was done with constant cycle, which is 4 cycle. So to achieve 90% and above dust removal rate, the cleaning cycle may increase, as it may affect the dust removal rate. So in conclusion, I would like to conclude that I successfully developed a control system of an autonomous PV cleaning brush controller using the DC motor driven brush controller, where I calculate the sizing of motor was calculated using the sliding threshold, friction coefficient, and else. The structure also has able to support the weight of the carrier motor and cleaning brush to make it run for a few cycles. To make it run for a few cycles, I successfully sketching the algorithm of the motor control system using the Arduino IDE software. So for the second objective, which is to analyze the DC motor parameters, motor rating, torque, and speed while deploying an autonomous PV cleaning brush controller, I observed and collected the data of the cleaning brush motor, where for a full load brush load of 18 brush, the speed need to run the cleaning brush is 61 rpm with torque of 3.015 Newton meter, and the carrier motor with 9.167 Newton meter of torque with constant speed of 30 rpm. With 18 brush slot, it achieved the highest dust removal rate of 86.80%, which covered 90% of PV surface area. So for the recommendation of this project, I would like to recommend the surge protector and insulation mats in PV installation site, where the PV installation site is full with electrical and electronic hardware, where it has highest risk to be stripped of lighting. So this protection can protect from heat and fire for all of the equipment in the shed. So for the second recommendation, using the limit switch as edge detector for the cleaning system, and it will act as a warning and a turning point of the motor when it exceed the rail. So lastly, the third recommendation would be the display of the cleaning cycle routine, where it would be displayed as the direction of the motors and number of cycles the system has run. So here is the published paper of PV cleaning system that has been published at KISS 2021, where you can find it at the website below, where I will attach at the end of this presentation. So that's all from me. Thank you.
Assalamualaikum and hi everyone. My name is Umi Sarfina binti Rosmati with metric number DE18016. I will be demonstrate the project title of Adaptive Position Control of DC Motor for Brush-Based PV Cleaning System. System was programmed by using Arduino coding, where it moved forward for 3 seconds and delay for 3 seconds, and then it moved backward, which is counterclockwise for 3 seconds, and then it repeats for according to the RTC system. So the system consists of 3 motors, which is carrier motor and the cleaning brush motor. The cleaning brush is attached to aluminium rod, and at the end of the shaft is a bearing, and there are upper and lower side of carrier motor. This is the lower side of the motor, where the wheels are made of rubber, and the cleaning brush motor is a DC gear motor with 12 watt of power. Motor control board system are attached in the left side of the shed. So the motor control board is in the acrylic box. So the circuit has a L298, which is a cleaning brush motor, the Arduino Mega as the microcontroller, and the MDD10A as a carrier motor driver module and RTC application. So the output of the L298 is attached to a male-female adapter jack and supply with a 12-volt adapter. For MDD10A motor driver module has 3 connections, which is on the left side is the lower side of the carrier motor, and on the right side is the upper side of the carrier motor, and at the middle is the supply, which is supplied by 12 volt of adapter below. The connection of both carrier motor is used by T-DIN special connector. For this application, we have an additional rocker switch, which we can control all the system by one switch, even though the supply are on, for all three of the adapter, which is L298 motor driver module, MDD10A motor driver module, and Arduino Mega adapter. That's the end of this project demonstration for project title of Adaptive Position Control of DC Motor for Brush-Based PV Cleaning System.